So hi everyone, we are from Group 17. I will be introduce our smart home security system. And the background and the concept of our smart home security system is to combine of multiple interconnected devices such as temperature sensor and surveillance camera to build up a security system. The system can provide real-time alerts and notify the users. So for the history of the security system is actually initially the humans use animals such as dog and ducks to alert the people. And when it comes to chains and bells, these things can be hanged on the door, and the door will be ring and alert the people when the door open and close. And next, it will become to a wired alarm system. Is actually build up a alarm system with hardwired, and eventually it comes to the smart homes smart security system. Is actually more wireless. So these are the two future trends in the cloud-based home security systems. Include cloud-based home security system and application of machine learning artificials. So for the cloud-based home security systems, it offers better flexibility, scalability, and accessibility. And this system can be easily integrated with other smart home security devices. And for the application of artificial intelligence, the security system may be learned from the data and react to the existing risks to protect the home user from any possible security breach. So actually the problem statement of the system may be, first of all, the lack of operability or compatibility issues. It means that device may be incompatible with other due to different manufacturers. And another is the privacy and the data security issues. The system can be easily to be attacked by the hacker and the data may be stolen. So the objective of our smart home security system is actually to detect any danger surrounding the environment of the house area. And secondly, develop a web application to view the historical alert data. And last is to develop a dashboard to analyze and visualize the sensor data. So this is our architecture diagram. In this architecture diagram, there are two sources to collect the data. One is from the IoT devices, another is from the camera. From the IoT devices, the data will be collected and go into IoT core. IoT core will send the data into a Lambda function, and the Lambda function will transform the data and store into the DynamoDB. So for another sources is from the camera, and the video will send to the install in the S3 bucket, and it will be trigger the Lambda to do the recognition on the video and return the response and save into the DynamoDB. So to build up the web application, we will be use the AWS Amplify API gateway and AWS Cognition. And for the AWS Amplify is to deploy our web application, and for the API gateway is actually for the website can be accessed to access the DynamoDB data. And for the Cognition is used for our user management. And lastly, we will come to the visualizations. We can use the QuickSight and Athena to actually visualize, analyze, and query the data from the DynamoDB. So next, I will perform the demo of this. How does it work? So first of all, I will be perform how to upload the IoT data and the camera video and store into the DynamoDB. And first of all, we need to prepare these two script, which is upload to S3 Python code, and another is to upload the IoT data into the system. So the first one, upload to S3 Python code, is actually to upload the video into the system. So we first prepare our image or the video, and we run this data, and the video and the images will be uploaded to the bucket, and the video will be triggered and store the response for the recognition into the DynamoDB. And next, to upload the IoT data, we will prepare a Python code to use the MQTT to upload the IoT data. We need to prepare this publish MQTT Python code and IoT data in JSON format. So when we run this data, when it say when we display connected, it successfully update the data into the system. So this is the data where we use to store the IoT data, and for this table, the DynamoDB table is actually to store the responses from the recognition. So the lambda that we use is, first of all, the upload to S3 lambda function, and the code is to when the upload the video, then it through the recognition and save the response into the table. And it will also trigger the alarm when it trigger the alert and send to the SNS. So we can see the response. So we can see the response. We can see the response in when one person detected at which time. And for the IoT lambda functions, we name it as SNS publish, and is trigger from the AWS IoT and go to the Amazon SNS. So for the code, it's actually to send the IoT data and send to the DynamoDB database. If the data appears any anonymous, or it will produce the warning and send the SNS to the user. So this is the example when it says warning. So when the smoke detected, so it will show the data. So next I will show the web applications. For the web applications, it's actually this. And first of all, we will go into the login. And it's because I actually signed in before, so I click sign in as you will see the alert history when the alert history, including the ID, the messages that created and the time which alert will be happen. And for the last one will be we will be use the quick sites and Ethernet to visualize and analyze the data from the DynamoDB. So how to perform? We will come to the quick sites pages and check is it in the Singapore. Make sure you change to the Singapore region and then click analyze and then click new analysis and click for the new dataset and click Ethernet and then name any of your data sources. So in this case, I will be type in like sensor data and leave it by default and validate the connections and create the data sources. And then we will be choose the Ethernet DB sensor data. And then and then we choose the table you want to visualize and analyze from the DynamoDB and select and choose it by default and then click visualize. Then click create. So this is the quick sites. We can click on this column or attributes and then choose two, maybe two to show how the data. Okay, so you can see that for the true one door sensor true, there's count for 1, and for the door sensor true count for 5 from the data from the DynamoDB databases to visualize in the quick site. So this is our overall architecture diagram. So lastly, I want to thanks for my group mate where they were hard work on this assignment, and that's all. Thank you.